Good afternoon. We are going to continue on in this video talking about conic sections, and we are going to talk about how to graph and write equations of hyperbolas. In your packet, you have about 9 examples of graphing. I'm probably going to do 3 of them. If you need me to go through more of those, please let me know during our live streams, or if you need me to create more videos. So, goal today, can graph hyperbolas and write equations of hyperbolas. A hyperbola parallels the ellipse in its meaning. So instead of having the sum of the distances from the two foci being constant, we're going to look at the differences of the two distances being constant. Really what it is if you could imagine cutting an ellipse in half and flipping it out along its major axis, then you would end up with a hyperbola. So it does go on forever, both directions depending on if it's horizontal or vertical. Instead of a major axis, we now have the transverse axis that goes between the two foci. Actually, it intersects the hyperbola at its vertices as well. The center is the midpoint of the transverse axis. That also helps us figure out where our asymptotes will go. And then the conjugate axis is the axis that's perpendicular to the transverse axis through the center. Information here for hyperbola. You'll notice in the equation, the big difference is that there's a subtraction sign in there. For an ellipse, a was always the bigger number in the denominator. For hyperbola, it's always the first number. And then you really have to pay attention to where the negative sign is. If the negative is in front of the y, that means it's a horizontal hyperbola, and if it's in front of the x, it means it's a vertical hyperbola. Pretty much everything else is about the same as far as finding information here when the center is at 0, 0. We'll use that here in a second when we go to graph. Here are some steps. You're going to determine if it's horizontal or vertical. You're going to plot the vertices. You're going to draw the asymptotes from the center using the slope, which is plus or minus b over a or plus or minus a over b. The biggest thing you need to remember is slope is rise over run or y's over x's. So that's how you're going to figure out which number goes on top. You're going to plot the foci, so we're still going to use c squared equals a squared plus b squared. I should say still because it's a little different than the ellipse. For the ellipse, we're subtracting. And then you're going to add that to the center to figure out where those will go. And then you're going to draw your hyperbola in around the foci and following the asymptotes. The eccentricity is the same as an ellipse. It's e equals c divided by a. But this time, instead of being between 0 and 1, it's going to be greater than 1. The closer to 1, the flatter the hyperbola. The larger the value, the more round it is. Okay. Same idea, if our center is at something other than 0, 0, we have that hk. So remember, h is always with our x's, k is always with our y's. Let's go ahead and graph a few of these, and then I'll probably do a second video where we look at how to write the equations. We have 3 of them here. The biggest thing I want to point out is paying attention to where those minus signs are. If the minus sign is in front of our y, that means it's horizontal. If the minus sign is in front of the x, it's vertical. So the first one would be horizontal, second is vertical, third is also horizontal. Oops, if I spelled correctly. And I'm going to go ahead and graph the first one just because it's the easiest. I should say that's where I have the most space. B will be very similar. The difference with C is just remember that there's a 1 in the denominator there. So center, there's nothing being added or subtracted with our x's and y's, so that's at 0, 0. Then we are going to go ahead and find our vertices. Because I know this is horizontal, I'm always going to use that first number for my vertex. If it's under my x, it impacts the x value in my point. So the square root of 16 is 4. It's under the x, so I'm going to do plus or minus 4 for my x for my center. My y will stay the same. For my foci, I need to find c first. So remember, c squared equals a squared plus b squared, which is 25. So if I take the square root, I get c equals 5. Okay, and I'm going to add this and subtract this from my center. Since my center is 0, it's plus or minus 5. My eccentricity is going to be c divided by a. And remember, in this case, a is always the first number. It is not going to be depending on where your x is versus your y, or which one's bigger. One other thing that's going to help us is to find our asymptotes. Let me spell that correctly. And then for our asymptotes, I just like to list my slope because I'm actually going to use it to make a rectangle. What I'm going to do is I'm going to find my y, because slope is rise over run, so y is over x is. Square root of 9 is 3. And then my x is going to go in the denominator. Square root of 16 is 4. So here's how I use that. I'm going to start with my center, and I'm going to plot that point. So my center is at 0, 0. Okay, I am going to use my asymptotes. I don't even think I said that first. I think I said plot the vertices first, so let's go ahead and do that. And then we'll do our asymptotes. So our vertices are at 4, 0, and negative 4, 0. And then I'm going to use my asymptotes, and I'm going to draw kind of like a rectangle in here. So from my center, I'm going to go up 3 over 4 in both directions. That's why I put the plus or minus on there. I'm going to go down 3 and over 4 in both directions. And I'm going to draw my asymptotes in. I'm going to go ahead and get some lines here. I'll extend these in a second and make that not so large. Make it dotted. Okay, so there's one asymptote. I'm going to do the same thing with the other one. Connect those. So I'm going to go ahead and draw a line here. Just going to go ahead and grab this one. And those help me guide how to draw the actual hyperbola in. So let's go ahead and fix that so they match. I'm going to do my asymptotes in blue. Make them dotted. Should have arrows on the ends because they go on forever. We're good there. Okay. Last thing we're going to do is plot our foci. And I'm going to go ahead and change those to different colors. So I have positive 5 and I have negative 5. And I'm going to go ahead and draw in my hyperbola. And remember, it is going to get close to your asymptote. Okay, it's going to hug your asymptote. In this case, it will not cross. Sometimes they do. Sorry, it's a really bad part of a hyperbola. And that's it. Let's do another one. For this one, I'm going to go ahead and do D. Actually, I'm going to do E. And then I'm going to show you a trick for F, just so you can kind of get used to seeing something like that. It does pop up every once in a while. So for this one, center, remember x goes first is negative 3, 1. So I took the opposite of this and opposite of that. For my vertices, this is going to be a vertical one because the y is first. So the square root of 4 is 2. So what I'm going to do is I'm going to add 2 to my y and I'm going to subtract 2 from my y. So 1 plus 2 is 3 and 1 minus 2 is negative 1. So that's where I'm going to graph those 2 points. To find my foci, I need to do c squared equals a squared plus b squared. So c is actually 2 squared root of 2, or just the square root of 8 if you want to leave it like that. Honestly, I don't mind. And I'm going to go ahead and I need to add that to the y value in my center because that is where our change is. Remember, it's vertical. So negative 3 will stay the same. I'm going to do 1 plus and minus 2 square root of 2. And I just noticed that I wrote an 8 there. 2 square root of 2. Okay, and then eccentricity, we are going to do c, which is 2 square root of 2, divided by a, which is always our first number. And I can simplify that, so square root of 2. This one's going to be pretty flat because this is close to 1. And then the one other thing I want to find is my slope of my asymptotes. So my slope is going to be the square root of whatever's under my y, which is 2, divided by the square root of whatever's underneath my x, which is also 2. So my slope is really up 1 over 1. Okay, plotting this, I have a center at -3, 1. 1, 2, 3, 1. I have vertices at -3, 3, and -3, -1. I'm going to go ahead and draw my asymptotes in. So from my center, I'm going to go up 1 over 1, up 1 over 1, both directions. So I'm really kind of creating a square or a rectangle in this one. And I'm going to draw those in. And I'm just going to leave them black this time, save myself some time. Extend those a little bit. Okay, and then I am going to plot my foci. If you find this as a decimal, 1 plus the square root of 8 is 3.82. So 1, 2, 3.82. And 1 minus the square root of 8 is -1.82. So -1.82. And then go ahead and draw in your hyperbola. So there's one, and there's another. And we're good there. Okay, not too bad. For f, when you do this, consider this is the same. Multiplying by 4 is the same as dividing by 1/4. So this would be your b squared is 1/4. So instead of having a 4 in front, that's really the same as dividing by 1/4. We're going to do h for the last one. I'm going to go ahead and set this up so I can do some factor by grouping like we did in the ellipsis. So I'm going to do 4x squared plus 4x. We're going to add something here. And I'm going to factor out a -9. So y squared minus 4y plus something. Move that 56 over. And then when you add this in, remember you need to multiply. So I'm going to go ahead and fill in. Half of 4 is 2. 2 squared is 4. So 4 times 4 is 16. And half of -4 is 2. -2. -2 squared is 4. So -9 times 4 is -36. So I really have 4 times x plus 2 squared minus 9 times y minus 2 squared equals 36. And then I am going to divide by 36 to get x plus 2 squared over 9 minus y minus 2 squared over 4 equals 1. And then I'll go ahead and list all this information out here. So center is going to be at -2, 2. Vertices are going to be over 3 sideways. It's horizontal because x is first. So I'm going to do add 3, which is 1, 2, and I'm going to subtract 3, which is -5, 2. Foci is going to be c squared equals 9 plus 4, which is 13. So c equals the square root of 13. So we're going to do -2 plus or minus the square root of 13, 2. Eccentricity is the square root of 13 over 3. And then our asymptotes is going to be up 2 over 3. Okay, I'm going to hit pause. I'm going to put this on the graph and then you can check it. Okay, and I have the parabola up there, so if you want to check it out, go ahead and hit pause. Remember, start by graphing the center and the vertices, and then use your slope of your asymptotes to go up 2 over 3 and down 2 over 3. And then plot your foci and go ahead and draw in your hyperbola hugging your asymptotes. Again, if you want me to go through more of these on video or in our live stream, please do not hesitate to let me know. In the next video, I'm going to show you how to actually write the equations. Have a great day.